Let's go. 1, 2, 3. I just explained this slideshow while we're waiting for 1 or 2 people to come in, but I just put it up there as a bit of a vision for you of a different kind of forest you might not be thinking about. This is one of the subsets of food forests. Forests mainly grown to grow food. So there are, we will go through a whole set of forests, the sets, variations of types of forests, and quite often you can mix them all together. There's nothing wrong with that. It's probably a very good idea a lot of the time. But then they obviously, if you just go into the set of food forests, there are food forests that are specific to climate particularly, and specific to landscape profile. And this is very much an arid land forest. I came across this forest in 1974. I was 20. I didn't know what I was looking at really. I was nowhere near taking a permaculture course at that stage, but it was kind of interesting. I remember it. I took some little Polaroid camera pictures of it actually, and I think we pinched some fruit out of it, or tried to. But I remember seeing this great big mixture of fruit trees all together with a canopy of date palms over the top. And it stuck in my mind because it sort of gave me this vision of like the Garden of Eden or the classic oasis that you see. And the photographs weren't much good and they faded over time. They were just little prints. And when I went to work in Jordan and we were looking at what was possible, being quite optimistic about what could be done, that this could possibly grow a forest like this, because in Jordan, in the Jordan Valley, they do grow bananas quite unsustainably with lots of pumped water. And I remembered that this date palm system, date palm overstory system, had bananas underneath. And having been brought up in England, born and brought up in England, I was always fascinated with bananas, and it was the first time I'd actually seen bananas when I visited southern Morocco. I remembered this system, and I had enough frequent flyer points with all the work I've been doing to take a bit of a holiday. And it's even hard to take a holiday without some meaning after a while. So I thought, well, I could go to Morocco and try and find that system, and maybe I could find other systems that were the same. And I started to research these type of systems, date palm overstory multi-species fruit tree systems. And there are quite a few variations. And I found it, as you can see. I spent 2 days in there, taking photographs, walking around, talking to people, and I found out a lot more about it. It has date palms in the overstory. It's mainly date palms in the canopy, and they're one of the hardest of arid land species and one of the most salt tolerant. And they shade the rest of it quite a lot. There's quite a lot of filtered shade, which takes off the water demand and reduces the light saturation. And then there's olives underneath the dates. That shot there's olives and old citrus. Olives are the next most hardy of the desert species, one of the most hardy, salt-tolerant, drought-tolerant desert species. And there's old citrus, varieties of citrus, oranges, lemons, mandarins in amongst the olives. which are supported by the other species because they're not so drought tolerant. That shot there is an old carob tree. There are carobs. There are guavas. There are pomegranates. There are some quince. There are figs. There are bananas. And there are broad beans, the broad beans, often grown. Interestingly, often grown as one of the main crops because they're fixing nitrogen at the same time as they're cropping. And there are ancient water systems, just open little channels coming down from further up the wadi on a very, very slow grade, very passive, very low tech. It doesn't look quite as fertile as it did 28 years ago, 30 years ago. It was 28 years later I got back and found it. I think a lot of the people from the village, a lot of the young men from the village have gone to town, gone to the city. This is the depopulation of the countryside. The expansion of the cities is extremely fast now, everywhere. And as modern agriculture fails, it's speeding up exponentially. And the consequence of living in the city is that you destroy more landscape, really.
They're basically all fruit trees.
Nearly all fruit trees. It's very much a climax system. There's you can see it's classic scarp and pediment landscape. It's quite dry. There are some mulch species. There are some reeds growing on the edge of the little water channels that take up some of the impact of the water where it turns corners. It's quite well established. There's 800 people in the local village and they communally own it, harvest it and work it. It's 2,000 years old. Not quite sure. It's just up behind Tarazout, north of Agadir, on the Atlantic coast. I think it's probably at about 50 to some. I would guess at 50 to 100 meters. Maybe I'm not quite right there. It's at the end of a big wadi. But what I'm interested in, the fact that it's 2,000 years old, that's pretty sustainable. If we can get an agricultural system today to last over 20, we think we're doing quite well. 200 would be wonderful. 2,000, that'll do for now. With some remnant of fertility left, 2,000 would be great. But actually to be in production is quite amazing considering what we're doing today. Even though it looks like it's lacking a bit of maintenance. And I would love to find another system like that had bananas underneath, because it's the same climate as the Dead Sea Valley where I've been working. And we could produce all of those crops quite sustainably. I've drawn up a schematic improvement of that design in some ways for the Dead Sea Valley. I travelled around Morocco looking for similar systems. I found lots of similar systems, but none with bananas, none with a subtropical variation of climate. There are cooler systems that have cooler winters in the eastern side of the Atlas Range there, Zagora going out towards Algeria. There are large date palm overstory systems. They have apricots in the understory and apples. Grapes. This one had grapes. They have a slightly different cooler regime of trees for the cooler winter. They're that bit further from the ocean, so they're getting the continental climate effect. This one's being moderated because it's a little bit closer to the Atlantic. So as you get over into the towards the true Sahara, you get the same systems, but they're cooler in winter, and they're probably a bit warmer in summer. And they have labyrinths of mud brick walls around the fields underneath. Little access tracks, and just big enough for a donkey to go down, with side packs of baskets for manure, carrying in manures and different organic materials. And they go off the horizon as far as the eye can see. You can get up on hills and look at the tops of the date palms, and they go off the horizon down the wadis. Amazing. It's kind of scary to go walking around in them. You don't know. It all looks very much the same after a while. And you're going down all these little laneways with mud brick walls, and they're all the same colour. And it gets quite confusing. You can get quite easily lost, I'd imagine. I only went so far and then found my way back out of them. So that's one type of arid land food forest. And one of the classic areas for these are an area you'll all know about geographically today. It's between a couple of places called Baghdad and Basra, right? Between two rivers called the Tigris and the Euphrates. You have the largest genetic diversity of date palms in the world. All the dates consumed in America before 1930 came from that region just there. And you've probably seen it on television just recently quite a lot. And if you search in the background of the footage, you could see a lot of this in the background. You could see date palm overstory multi-species systems and conflict. You know, if you were watching the soldiers, you didn't really see much, but if you're looking in the background, it's kind of interesting. You could see it. There are many places where there's date palm genetic diversity, but that's the best one, just there. And these are incredible recovery systems. We could have massive systems like this out through Australia, actually. We don't have the genetics of the date palms, and you really need to select suckers and divide suckers off. You don't get a true you don't get true production, exactly the same production from seeds, and half of them are males as well, so you won't get a true to strain date palm exactly from a seed cultivar. So usually they're spread by suckers. And Alice Springs has our oldest date palms. They were planted by the Afghani who opened up a lot of our interior with the camels. So that's a very interesting type of forest, very stable, very productive, sort of a vision of an oasis. And also in Morocco, there's something else that they do with one of our trees that's kind of interesting. And that's one of our eucalypts, or maybe two of our eucalypts. There's they grow all their firewood. Yeah, and they grow it like this. These are eucalypts. And there they are, just harvested, and the trees in the background are just about to be harvested. And this is a coppice eucalypt firewood system. Endless production of firewood of a regular size, regular production. It lengthens the age of the tree. When you coppice trees, you extend their age, if you do it well, and you do it well because you want it to regrow. And it's kind of strange. There's some really humorous things go on around the world with species of trees appearing in quite ironic places. Sometimes I think there's someone in the creative forces there has quite a sense of humour. Most of the Middle East is pioneered by American trees, actually. Prosopis. you know, and a South American called Leucaena, and quite a lot of the Balkans. And here we have Moroccans growing most of their firewood with an Australian tree, and yet we don't do it. And this is a European system of culture coppice used by North Africans with an Australian tree. Not at all prejudiced, they're doing pretty well. Just to go back, there's the regrowth, they're starting to come again. And 2 years later they'll be back, pulling their firewood back off it. And this is kind of monoculture of firewood. In the background here, where I'm pointing the cursor, that's sort of half grown, and at the top of the hill, those trees there, that coppice, is about to be removed. Right. Coppice should take them right off. So in that classification of forest fuel, one type is coppice. And you have coppice down low and pollard up high. So when you take off a coppice, eventually they'll actually grow a great big callus on the top, like willow baskets do, and they'll grow like this. Some of the oldest trees in the world are coppices. Some of the oldest oaks in Europe are coppice. Some of the oldest chestnuts are coppice. Depends how long you let them grow. It will grow into a great big branching tree. Like most of our camphor laurels on the north coast of New South Wales, they've been hacked off by a tractor when they were younger. Now they're great big spready trees. And, you know, much to the disappointment of the Chinese, who really want to buy all our camphor laurels, but they haven't got a lot of millable timber in them. And they will seed, and yeah, they'll fruit, yeah. Yeah, if you leave them long enough, the idea here, this is how willow baskets are grown, and great big long whips. And if you go into areas where they grow willow coppice, in the winter, when they've cut them all off, it looks like these giant big mushrooms everywhere. They're the big woody stools. And the eucalypt coppice is the same. They'll let those eucalypts grow, sort of stump something like this. They'll let them grow for a couple of years until they have a really regular, they want something the size of a small branch, and they're letting them grow to be something about 50 mils. And then they've actually designed their cooking system, their stoves and their heaters to receive that size branch. They've worked out that that's the size branch, or that's the size wood that gives them the right sort of heating or the right sort of cooking. And they've actually designed their stoves around the trees that will grow in their area that will coppice and give them ease of production. And they never need to kill another tree. In fact, they're lengthening the life of the trees.
But with the eucalypts, because of the lignin issues, they're absolutely ideal for them.
Yeah. I don't know that anybody's done any full research on all the different eucalypts you could coppice. And obviously, not all the trees of the world have been analysed either, because it's a culture that only appears here and there. But wherever you go around the world, you see trees that are coppiced, or a high coppice, or a pollard, a bit higher up again. You see, whenever you see this pattern, whether it's for ornamental pruning or for some functional pruning, stop and have a look. It could be it often is something really interesting. It's often some sort of fuel. It can be some sort of fibre, it can be some sort of craft, or it can be some practical function of growing sticks to construct something locally.
Is there a rule of thumb for one season?
I think normally it would be the dormant season. So you'd cut off at the dormant time, and not too late into the dormant period, right, I would imagine. Most of the time, this is how it happens in cold climates. So the tree gets a nice clean cut, recovers, and then it gets a whole growing season of recovering the material, because you're after the material. No, they take it all off. if you want it to grow back to a straight tree, you select one and keep all the others off. That's how you grow Paulownia. And you let it regrow. If you're going to grow your Paulownia trees, the trick of growing a Paulownia is that you often start off with a root cutting, right? It grows from a little bit of root, and it's got to grow 20 foot in the first year, which it does if you do the right thing. It grows a little top on it like this, and then after 7 years, you've got a pole, a reasonable sized pole, or you can let it grow on for like 60 years or 50 years, and you've got a big millable piece of timber, but mostly they're grown for poles, and then you cut it off at 7 years and take that pole. And when you do that with a Paulownia, it coppices from the bottom here, grows a whole set of regrowth, and the thickest one you let grow, cutting all the others off, and you want that one to make 20 foot in the first year of letting that go. And you do that 7 times, 7 or 8 times. So you get 7 or 8 poles off your one Paulownia. That's the theory, right, if people have got it right, of growing Paulownia for poles, which is reasonably valuable timber because it's got certain qualities. So that's a way. Now you're going into different sort of forest now, right? We're going into so you have fuel forest, one type, and there are many types of fuel forest. So this is forest types. I really want you to think about this because people tend to classify forests a little bit too quickly. There are many types. So you have fuel forest, and then you have pole timber. And that is specifically for doing this sort of thing, growing poles. The Paulownia you can cut off and grow repetitive poles. But then you can grow eucalypt poles. And of course, in the pole timber itself, there will be subsets of fuel forest as well. Each type of forest has a subset to itself. So there will be types of fuel forest. Then there will be types of pole timber forest. Paulownia would be one. I think that's it. No, it's not, is it? There's a W in there somewhere. Sorry? There? You know what I mean. Okay. P-A... yeah, it's a Chinese tree. Then you get eucalypts, and you get, what am I thinking of? Bamboo. Could be classified, there are types of bamboo as pole timber. Bamboo is probably a whole system to itself, actually. Very specific. There is very specific forage. There are many sets of forage, right, depending what you are feeding. There is chicken forage. Drops a lot of seed. There is cow forage. And the great thing about cows is they eat enormous variation of things. About 30,000 plants that we don't eat worldwide. So they're great converters of vegetation that we can't eat into really useful proteins and materials. Horse forage is quite different. Horses are a lot fussier. And there are whole sets of those. There is bee forage, a specific set of trees you plan out for bees, and you clump plant your bee forage. Because when your honeybee leaves the hive, it only goes to one type of flower on each flight. So you can't spread these out. You do need a clump of one species if you can. Clump your bee forage and reduce the energy needed for the bee to harvest. And you need to line up for your bee forage, you need to line up wherever possible good windbreaks for them to fly back. So as you line up your other forest systems, you can line up wind-free flight zones for your bees and really increase the amount of production in your hives if you're just having stationary hives on a property or at a location. Because bees suffer a lot from flying in the wind fully loaded. They use up a lot of energy. We have structural timber. Or we could call it sawn timber. And again, that'll vary depending where you are. And can be quite hard to establish in high quality. High quality sawn timber is usually quite slow growing large trees. And especially if you're going for high quality timber, really high quality, slow trees that are very slow growing, long lived, has almost never been achieved as a planting. When it comes to the very high quality sawn timber trees, they've really only been harvested out of wild systems, and it's very hard to find anybody who's achieved replacement plantings of such high quality species. When you're talking about the highest quality timber that you can find, it's harvested once and not replaced. Usually the replacement is a much lower quality timber. As you find here in Australia, what was rainforest, when it regenerates, often the degraded, slightly degraded land comes back as eucalypt forest. There are ways of managing forests sustainably and getting high value out of them. And I've been involved in some of that in the Amazon with indigenous tidal. And in the Choco rainforest on the border of Colombia and Ecuador. One of the hardest things was to protect forest in the first place. I was involved with organisations that got indigenous people their land rights, but then how do you know where their land starts and finishes in the middle of a rainforest? You can't, because you can't fence it. You can't demarcate it at all, really. And colonists move in. Because the land is free to colonists. That's a law that was set up in 1942, which Daniel could probably tell you quite a lot about coming from Colombia. But colonists can take, in Brazil it's 100 hectares or 50 hectares in Ecuador, and if you show agricultural use, which means usually clearing it, you get an opportunity to own the title. And it was a way of opening up the Amazon, and those laws are still in place. So wherever you get a road, you get colonists going down the road. So, especially oil roads, which open up often out into remote places to put down oil wells, because the subterranean rights are sold by the government to foreign oil companies. So I was working in the back of Ecuador in some of the richest terrestrial ecosystems on Earth. And we were working in a block called the Maxis block with the Guarani Indians. And Maxis is an oil company that I don't really know very much about. Texaco is the largest oil company in there. But Maxis is pretty well off, I think. We were told they had an annual economy that was 18 times larger than the Ecuadorian government. So they were pretty big. and they were putting in oil roads through the indigenous territory that we'd actually worked to demarcate for the Waorani Indians. And it's always the case that when an oil road goes into the Amazon, you'll get an oil road go in to a well somewhere, and all the way down that road, and it might be quite long, you'll get 100 hectares taken out like this. They're usually 1 kilometre deep. It's a long rectangle, and they just go all the way down the road, and then they go 1 kilometre back from that. There's a second row, and then there'll be a third. Then not often is there ever a fourth, because by the time you've walked 1 kilometre, 2 kilometres, you're going to walk 3 kilometres through this environment. You really are tough. You can go and do it if you want to, but boy, you have to be tough. These are very, very tough mixed blood species of people. I mean, this is deliverance country when you get out here. This really is. Am I not right, Daniel? This is very dangerous stuff. And these are very, very tough, desperate people. And very strong, genetically bred. And all rivers and all roads are cut like this. And it doesn't matter that this is indigenous territory just here. It just, they don't sit, what's the line? And we worked with people, and what we did was we cleared a 5-metre strip round 2 million hectares of the Waorani country, 5 metres wide, and that in itself is very hard work. And we transplanted palm trees in here from the gullies. And after a while, the palm trees grow and they shade out this area, and it's very little maintenance to keep this area clear. And when you come walking through the forest, it's obvious there's a line of palm trees. And it was the first recorded case of stopping colonisation coming down an oil road in the whole of the Amazon as far as we knew. And that was working with the Rainforest Information Centre of Lismore. John Seeds, the main founder there. And it was Bill's advice to tell us to do this. It was Bill who told us that that's the only way you can do it, is plant one species of tree in a 5-metre clearing. They were kind of freaked out to start with. So we're trying to save rainforest. You're telling us to cut it down. But it's the only way you can mark it. And it did. It has actually saved an enormous amount of rainforest being cut, because it is a demarcation process where you can see that if there's something going on, there's a whole line of one species of tree. And they're palm trees. They easily transplant out of the gullies in the surrounding forest. And the Waoranis are pretty vicious, and you could get killed going in and doing anything in their territory. In fact, they speared 7 Shuar Indians while we were working there, who are cutting, burning and grazing country for cattle. And they came over their demarcation lines. So it was an advantage that Waoranis were very, very fierce people. And only contacted in the last 20 years. In fact, they have a group that's only just been contacted, the Taigeri. That's been called linduration. It's a Spanglish word, half English, half Spanish. That's one way of protecting forest. And then working with other groups, including the Waorani and the Awa Indians on the Colombian Choco forest side, which is richer than the Amazon actually in species. We worked out that if you did a survey of the forest, you could take out 11 trees per 1,000 hectares a year, and it would still be reasonably sustainable and would recover very well, and you could carry on doing that. And if you walked in a mobile mill in pieces, dropped your tree, milled it up on the spot, left all the trash there, dismantled the mill, walked it back out, walked out the sawn timber, and then we had contracts with Scandinavian music instrument manufacturers who wanted sustainable timber, we could get the Arwar Indians in 1 year what the logging company was going to give them once for a clear fell. And they keep their forest forever, and they could get the same income every year from logging 11 trees. And the logging company promised them roads and generators and four-wheel drives, and the four-wheel drives and generators all break and then no longer get maintained. And we showed demonstrations of what had happened before and put up slideshows what happened before. And roads, you've got roads everywhere. It's all a bloody road just about. It's just a cleared landscape. There are roads everywhere. They don't last very long either. You might keep one or two, but most of them go. And when we showed those pictures, they quickly decided that our system was better. And the Rainforest Information Centre has used those same strategies in New Guinea. It's pretty heavy work. The logging companies don't like you. And there are often corruption and all kinds of things going on in these countries. And you could get yourself into big trouble. But if you want to do that sort of activist work, it is out there and it's quite important. But it still doesn't answer the colonist thing. It still doesn't answer how you're going to stop desperate people trying to grow food and get an economy. But it does save some of those last precious biosphere reserves. I'd like to get on to establishing food forests because I think they're some of the most interesting of systems and most sellable to people, and most of us probably want one if we thought about it enough. But the general system of establishing a forest that is long-term and hopefully low maintenance gives us a clue into the food forest of how we establish those. These are something that you're interacting with intensively and regularly over a year because you've got endless yields coming out of a food forest, where a sawn timber forest is something really ideally you need to establish as quickly as possible and stop interacting with, because the yield comes out in 25, 50 or 100 years and hopefully continuously from then on. So that's a different attitude of establishment. That's zone 4. You don't want to be out there maintaining zone 4 for years and years and years and years and years. You can't afford to be. And yet it is still important. So what I've just spoken about before was about conservation really of systems up. Let's talk about this one a minute, sawn timber. What a lot of forestry departments are doing around the world now are locking country up and letting it pioneer in the native species, like gorse in New Zealand, and broom, and other acacias and all kinds of pioneer trees, and then moving in at a stage when there's a dominance of pioneers and planting more advanced timber amongst them. And sort of they've calmed down, they've become more passive and let the natural system put the primer down. They might prepare the ground, like painting this bench. So you'd prepare this, you'd sand it down so it would receive the primer. And then you paint it with primer, then you paint it with undercoat, and then you'd get the top coat to stick on it. You can think about it like that a lot of the time in applying a system down on the ground. So there's some interesting stories in New Zealand when the Maoris got a lot of their land rights. They were given back quite a lot of country that was cleared grazing country, and they just kept it locked up and didn't do anything. And the whole landscape covered in gorse, and introduced legume from Europe, thorny bush. And a lot of the local farmers cursed them, said, "Oh, you Maoris, you're doing nothing with the land. You're good country. You're just letting it go to rubbish." Typically demonising the pioneer plant, especially as it's a foreigner, right? Letting it all go into rubbishy stuff. Well, they just said, "Oh, go away. We're not interested in what you think. It's our country." And within 10 to 15 years, patches of wild tobacco started to come up in the gorse. And where the gorse had mulched itself and mulched itself and mulched itself and increased the humus in the soil and put quite a bit of nitrogen fixation down in its roots, that wild tobacco had come up in the thinner patches of gorse, and you get little groves of wild tobacco. Well, the only birds that eat the wild tobacco berries are forest birds. So these forest birds fly in and put down forest seeds. And native New Zealand forests started to come up out of the wild tobacco groves, as Australian rainforests do out of wild tobacco groves here. And then these native forest groves started to grow, and the wild tobacco became a fringe of the native forest groves and gradually started to grow out the gorse. And over 20 to 30 years, you've got patches of forest which, in a real estate sense, all of a sudden are worth more than the grazing country, because we're all getting sentimental about forests. And a lot of the Maori people did that by doing nothing. By just sitting there and watching what's going on. So a lot of the time, if you were looking in Australia, you're looking a lot of time at height and time. Our forest might climax out at about 60 metres. Quite a lot of it. And we're here at 2005. If we forget about our lifespan for a minute and we go out to 2155, if there's anything left. And at 2155, there'd be a big forest here if we left it alone. We just walk away from a patch of land on average, on a lot of the east coast of Australia, you just did nothing. Find a piece of land, lock it up, decent piece of land, lock it up, lock everything, all the people, all the domestic animals off it, it'll be there. But it will be a little bit of a slow takeoff. It'll come up really slowly, and then it will start to lift up to a climax like that. Some sort of curve. But this is where we tend to interfere with it. And it's going like this. Oh, there's weeds, knock them down. Oh, there's weeds, knock them down. Oh, there's weeds, knock them down. Oh, there's weeds, and you never get there, you never lift. Because we're prejudiced about the pioneers, which we call weeds. What we really need to do is to think about their function in this part of the curve. What are they doing? And increase the speed of the curve. This is the really interesting bit, actually, just here. Once you start lifting into forest, it'll go on its own. All kinds of environmental influence comes in, helps you along. You get an assist. And there's been some interesting work done establishing forests with putting in cabinet trees in the northern New South Wales, southeast Queensland area, where a minimum diversity of 3 species put together in a very tight pattern has been used. So silky oak, Grevillea robusta, blue quandong, Heliocarpus grandis, and crow's ash, Flinders australis, are all what are called light-demanding rainforest trees. They're quite fast. They're not the highest quality of rainforest trees, but they're pretty good for the type of trees that are generally grown today, and they're not the type of trees that grow in a plantation. You put them all, if you put a monoculture of any of these together, they don't grow. So this fellow Robert Koeman put together this minimum diversity, and he came up with a system of planting them 4 metres apart in a triangle like this, which is very close. And he went right across the landscape like that, with them 4 metres apart. And with the triangle system like this, there's never 2 together the same. So you've got, this is 1, 2, 3. So this is 1, 3, 2, 3, 2, and they're never with 1, 2, 3, 3, 2, 1, 2, 3, 1. You can always separate. They're never 2 the same exactly next to each other. More or less going across the landscape. And within 18 months, if you've got reasonably good quality seedlings that you're putting in, and you're putting them in at the right time of year, just before the rainy season, within 18 months they've canopied and they're touching each other. They're more or less shading out the ground. And then from then on, they race each other up. And if you get it right after 18 months, there's just about no maintenance. There's a thinning at 5 years. What's really interesting is that Koeman also planted 8 long-term, slow-growing 8 long-term, slow-growing, very high-quality fruit timber trees inside the 4-metre triangle. These are the trees that have never been regrown. They've never been grown specifically as timber trees. These were cut once out of the Australian forest and never replaced and never regrown. The quality of the landscape was degraded in the original cut beyond what they could recover. These are the classic fiddlewoods and very slow-growing trees. And not all of them succeeded, but some seemed to get lifted behind the crow's ash, silky oak and blue quandong. And some didn't. Some didn't make it, some went crooked. He overstacked the system. He what I like to call overstacking. I'm a terrible overstacker. I always put too much in. I'd much rather have too much in there and cut it out afterwards than be left with a hole that I can't replace in 3 or 4 or 5 years' time. You can't put a 5-year-old tree in. You can cut out the ones that are too many or too dense. Yeah, he talks about specifically putting in the access tracks for the 25 to 50 year first harvest. Somewhere between 25 and 50 years, you start to get in the first millable silky oaks. And you have to be very careful about the way you put the access tracks in. And you probably have to go into reasonably high-tech harvest machines like the new 30-ton excavators with the grab and the chainsaw on the end that can take out the vertical stick and things like that. But at the 5-year stage, you do the final culling of some of these and some pruning and walk away. And also at the 5-year stage, things started to come in, like palms and ferns started to enrich the system. And it's a very interesting system. We've laid a few of them down. We've had a few variations of effect. We've had a few problems at times getting high enough quality trees to plant into the system. You need very good trees that you're planting, very nicely grown pot-grown trees, not pot-bound and not too stunted. Well, they were all native trees of the area, right? that were the very slow-growing, high-quality trees of the original rainforest. This is literally a rainforest timber plantation. There was numerous species. I'm not that well up on exactly which ones.
So just rainforest.
Yeah, yeah. There was kerries, there was red cedars. And it looks very crowded. It looks very packed. But actually, have a look at the way nature regenerates. Have a look at what happens when you do a lot of earthwork. Sometimes happy little accidents happen. I often say that a permaculture group mainly shares lots of happy little accidents and sad little failures. So we can fast track our action. And you'll see that forest regeneration happens centimetres apart. Trees come up like hairs on a dog's back, and they self-select. Right? No way we can do that exactly, but we need to stack in more timber. And around the outside of the grove, you'll notice that Kooiman didn't put in any pioneers. Around the outside of the grove, you can lock it off with pioneers. But what Kooiman did was he went in and he sprayed the ground first with a herbicide. I don't do that, and never have, and never will. What I did was I went through and deep ripped it with a ripper, and then I went through and cultivated the surface and put down ground covers and pioneer seeds that would grow bushes like pigeon peas and crotolarias that will grow from seed very quickly and are short-lived. So I used what is really a food forest technique that I've developed over the years, right, in a long-term timber plantation. Now, if I start to explain that now, it's going to get very complicated, right? Because what I've already told you is reasonably complicated, yeah? What he's done. I'd rather bring that in here. Right.
Jeff, it seems to me that this forest will be very dense.
Yes.
How do you extract your timber after harvesting?
Carefully. That's all I can say. And that's the same when it comes to a food forest. A food forest, like the one you saw before, is extremely dense in the number of trees in there and the variety of trees. And yes, harvest is difficult. But then you either want to be sustainable or you don't. And one of the criteria for sustainability is interactive diversity. So you do have a few challenges in all of these systems, and you have to think about it. Right? It's not thoughtless, protracted action. It's thoughtful observation, right, with careful action. So, yeah, you have to think, when you're laying this out, and this is tax-deductible action nowadays in Australia. We've got people who've got, they put these in for economic reasons, and they've got tax deductibility for the establishment, right? And yet they're not going to get a yield for 25 years. But you've got to think about where you're going to get the logs out at the end and how carefully you're going to take them out so that you don't damage the trees in the middle that carry on going. Because if you get this right, this system is endless harvest. Just so happens you've got a reasonably economic harvest of some of these. You don't necessarily take them all, right, at 25 to 50 years. And yes, you have to carefully harvest them. But the technology of harvesting timber is coming up very high now.
Harvesting with horses in some parts of the northeast.
Are they? Going back to horses. Yeah. On the other end of the scale, the high-tech systems, a 30-ton excavator has a 10-metre reach. Right? And you can go, and it's got a chainsaw and a grab on the end. And it can cut the tree and pull it out as a vertical stick. Right? This is a 25 to 50-year-old tree. And then it can trim off and mulch all the branches and leave them on spot. Right? And just take out the stick. So that's the sort of high-tech side of things. But then even, crooked and curved timber is coming up in price. When you know, some of the high quality rainforest timbers are now $1,000 cubic foot. And it's not going to go down in price. It's just not. You know, very low quality timber in New Zealand, macrocarpa, which 20 years ago was burnt and trashed, is now called poor man's kauri and fetches a good price. So you have very careful access planning. So you're still going in saying water access structures. And your access, as we've talked about, can be a water harvesting feature to assist, you know, the production that you're after. So, you know, if your access tracks are on contour and they're harvesting water to your growing system, it's all beneficial. And these are access tracks that are not continuously used, so they don't have to be, you know, hardware gravel tracks. They can just be actually benched out earthworks, but they can also be harvesting water. You can, so if you lay it out properly, you can multi-function with your access. So not quite as simple as you think, reforesting landscape. You get a lot of clients that don't understand this, and you go in to do a consultancy and you say, what are you going to do with that 20-acre hill there? And they say, oh, we're going to reforest that. And I often smile and think, oh yeah, you obviously haven't tried planting trees all day and then see what happens when the grass grows all over them, you know, or, you know, it's just not as easy as you think. It takes careful planning. Often it's better just to condition the ground, lock it up and let it reforest itself and ignore the weed problems that happen and all the prejudiced attitudes you get from your neighbours, because you know within a few years the weeds are gone and the native forest has recovered itself. You might not get a choice of what trees come in, but the native recovery is often a lot more efficient than yours, and you don't waste all that time working and not getting the result you want. Often take a lesson from the forestry departments of the world who are letting areas pioneer and then planting into the pioneer growth. It's easier to let an area pioneer to the weeds or pioneer growth than go in and chop holes in it and orchestrate a variation of the forest that was going to come up. Right? Chop a hole in your gorse and put the timber tree in or the fruit tree in you want. Chop a hole in the lantana and use the lantana as mulch to the tree you want. Chop a hole in the blackberry grove and plant a tree in there and go in there occasionally and mulch it with blackberry. That's very close by. That's quite efficient. But to actually go out there and try and mow around it, don't even think about it. Because when you do the energy audit, it's incredibly bad.
Do you have any examples of the gores, for example, maybe photographic examples of reforestation with gores? I work with gores. I work as one of these sort of scarers who rip out gores and paint the poison on and whatnot. I don't really like doing it, as you say.
The New Zealanders are the experts on gorse because it's such a problem in New Zealand, and Joe Palaish and quite a few people over there have had great success in removing gorse and working with gorse because it is a legume.
This is the clip my boss, you know, has always done it this way, and you know they want to see visual progress straight away, and this is the sort of the mentality sort of dealing with.
Yeah, it's very hard when you're impatient and you're totally prejudiced about the plant. You can see no good being done by the pioneer. If you can set up a few trials where the pioneering species, which is locked up the landscape and is mulching the landscape and protecting the landscape, if you can set up a few trials demonstrating that that can be used as the precursor to forest, which it truly is. Right? Landscape doesn't stay in weeds. It goes into the climax forest. It's just a matter of time, and it's a matter of studying that timeline. Even giant weed species like camphor laurel, which are enormous trees, are very large trees, right, are just simply an insignificant understory of the eucalypt forest within 100 years. And they are perpetuated by grazing. Quite often you go on a consultancy and you say, has this landscape been grazed? And the client will say, no. And you look at it and you think, no, it has. I can tell it's been grazed. Because it's just not dense enough in the weed canopies and the mulch, the mulch production and biomass production. No, we haven't grazed this for 20, 30 years. And you say, well, it looks like it's been grazed. You're sure there hasn't been, just a little bit of graze? Oh, well, just 1 or 2 cows now and again. That's all it takes. And they will specifically often only eat certain species. And they will definitely go for a lot of pioneers. And they will go for, because they're nitrogen fixing, they're often high in protein. In Australia, they'll often go for the young acacias. But they won't touch the camphor laurel, because it's got a camphor oil in it. So the cows sort of favour the camphor laurel. And the camphor laurel allopathically doesn't let a lot of things grow near it. But the eucalypts will beat it in the end. The eucalypts will go over the top and they're 5 times higher. And it then fades out in the understory and becomes just part of the understory. You won't beat the weeds. You won't beat the pests. You just have to work out how they fit into the ecology. They're here. Let's talk about this nitrogen fixation side of things so we can understand what some of these pioneers are doing. Right? And then we can lay down a food forest, which is an interesting system. And it'll give you a little bit more of an understanding about forest establishment for all these different purposes. Because they can be laid out separately or mixed up, and they can very nicely be patterned. They don't have to be blocks, they can be strips, they can be down access ways. Don't limit your design thinking around blocks and areas and particular types. All of this can be mixed, as well as stretched and scaled up and scaled down. When you got this little leguminous plant or tree, it's something in the bean family. On the roots are nitrogen nodules. Can you see that dark green at the back? Yeah. I don't like the pattern, so I'm going to do a different pattern. Let's do something more like a leguminous tree. But all your beans and peas, they're leguminous species. And they have these little nodules on the roots. This is not the tree. This is a bacterial colony, Rhizobium bacteria. Rhizome meaning roots in Latin. So when you have a close look at one of these, this is the root pushing its way through the soil. It has a colony of bacteria attached to it. This is a nitrogen-fixing bacteria, a colony of nitrogen-fixing bacteria, and they associate with this particular tree. Some types of nitrogen-fixing bacteria associate with many types of trees, some are specific. And it produces a byproduct of nitrogen, which it gives to the tree. And then the tree, it produces starches and sugars through the photosynthesis in the sun, from the sunshine, so it has starches and sugars that it gives. It gives starch. To the colony, or they take it. So there's this exchange. In natural systems, there is no give without take. There's no take without give. It goes both ways. And so there's this partnership going on in the soil. And nitrogen grows leaves. As a fertilizer, it's something that promotes leaf growth. And the leaf growth of these pioneer trees drops mulch to the ground. So they're fast mulchers. The mulch creates humus and protects the soil. And this is part of their function as pioneers, to grow quick, mulch quick, drop mulch down. They're amazing, actually. Trees are just amazing. You don't need a miracle. Just have a close look at trees. These pioneer trees, they're fast carbon pathways. That's another way to think about them. From the sun through to the soil. They're fast carbon pathways. That's a good, positive description of a weed. They're a fast carbon pathway. All the water in a tree is hanging from the leaves, you know. It's one column of water. It's a column of water going all the way up. There's the water's hanging from the leaves as it transpires off. There's no break. There's a hydraulic all the way through to the roots. Scientifically possible to about 200 feet. Impossible to 400 feet. And yet trees, giant redwoods, go up 400 feet plus. Don't know how to do it. Hydraulically, it shouldn't be possible, and yet they do. So these trees have a lot of nitrogen in their body. So they have bean-type seeds. And leaves, actually seeds are the highest in nitrogen. The hierarchy of nitrogen is seeds and pods next, and then leaves, the leaf, the twig, the wood. Quite often the wood, even the wood is 5% nitrogen in a leguminous tree, so it often rots quick. Even the wood rots down quite quick. And these leguminous trees and some non-leguminous trees live in a partnership with rhizobium bacteria attached to the roots. And when the tree dies, the root net itself rots out as compost corridors in the soil, because the nitrogen mixed with the carbon in the roots makes it compost quite quickly. And you get this beautiful aesthetic pattern in the soil of the root net. You can't imitate that pattern with any type of machine. You can't. It's very crude to think you can rip it or Wallace plough it, anything like that aesthetic pattern. The aesthetics of that pattern are as good as it gets. It's a dendritic pattern going backwards from the trunk. It's a perfect root net drainage pattern. Compost corridors in the soil. So we know this is going on, and this actually changed agriculture 800 years ago, when you realised that if you rotated crops as beans and peas seasonally in between other crops, you seem to improve the soil. So it was a real revolution in agriculture quite a few hundred years ago. So if you take this on up to trees and larger species, interesting thing is, if you select leguminous species that regrow when you cut them, you can cut this and cut all that nice rich mulch off and remove it, and the tree will regrow. So you can cut it off at the right time of year and put it down as mulch. So you take all this off and put this nitrogen-rich mulch down. But a tree is a pump, and it pumps in relation to its transpiration area of the leaves to its root area that it can suck from. So proportionally, it can't suck now. If you take all the leaves off, it can't suck from anywhere near the same area of root. So it now shuts down proportionally. So when you prune the top, you actually prune the bottom. It self-prunes the bottom. And it cuts off all those roots. It'll regrow this way, and it'll regrow this way quite quickly. If you choose the right species, be careful. Like everything, not all of them do it. Not all of the legume trees, most of them. And not all trees coppice and regrow. But when you do this, all these bacterial colonies here, their starch supply cuts off. So you get a great big dump of nitrogen. That immediately is food for soil organisms. And it's the life in the soil that structure the soil. It's the life cycles in the soil that fertilize the soil. And their life cycles are very, very fast. So millions of little organisms come in to grab that nitrogen, and they only live for a few minutes or a few hours, and they die, and their bodies get eaten by other organisms, and they don't live very long, and their bodies get eaten by other organisms, and you get what you call a migration of nitrogen away from this point. More and more stable all the time in the bodies of these organisms that are living and dying on that food supply that you just created by shortening up the top of the tree, and the tree shortened up. So what were you doing there? You were speeding that curve up. See that curve up there? You were looking at the weed cycle, and you were orchestrating it for a minute. Okay. So suppose we were in a forest. Let's think about food forests, because they're pretty sexy sort of things. Right? These trees grow fast. We know that. They perform like that in nature. They grow quick. And they're friendly. They drop down nitrogen-rich mulch, and they have these nitrogen on the roots. So we're probably going to pioneer the ground with quite a few of these. There are ones that are short-lived. There are ones that are, well, there are some that are tiny little herbaceous plants, like clover is a legume, and beans and peas are a legume. And some of the oldest trees are legumes too, or quite old, large, giant trees. And there's everything in between. So you can now choose user-friendly legumes that imitate your weeds, user-friendly legumes that imitate your short-lived fruit trees, user-friendly legume species that live as long as your fruit trees, and a few gradations in between those too. So what I'm explaining to you is not just physical space stacking, I'm describing to you time stacking. And that's pretty revolutionary new stuff. Because no matter how many of these old systems you go and see, like you go and see that 2,000-year-old food forest in Morocco with date palms over the top and 12 different species of fruit tree underneath, there's nobody around that can remember how it was established. You go up to New Guinea and see some of those amazing, diverse fruit tree systems they have up there. Nobody can remember how they actually started them. And when I got involved in trying to establish perennial tree systems after taking my permaculture course, this is the thing that really grabbed me. I thought, there's so much written about fruit trees, I'm surely going to find out all about those, because there's loads of books on them. But who the hell's going to tell me about leucaenas and acacias and tipuana tipus and schizolobiums and all these strange things that do these functional, pioneering, cycling and nutrient, nitrogen fixation, phosphate fixation with fungi? Who's going to tell me about this, what I've termed the support species? So I started to sort of get really interested in finding out about these, and then it's led to finding out about them in all different climates, and you find they are all over the planet, and there's all variations of this behaviour going on. It's pretty easy to find the damaged ground. If you take interest in the recovery mechanism that nature performs, it's all over the place. You could see it right outside of here. You see it everywhere. Damage is just about everywhere. So here's all your pioneers that you've planted and orchestrated in, and here are your fruit trees of different types as well. So your fruit trees are in amongst them. Little tiny fruit trees at the beginning, shaded, sheltered, like in a shade house of pioneers, getting themselves established. The nitrogen fixation is going on near them.
What are the large trees again, Jeff?
Pioneer trees, these are the legume trees. Let's just say these are the nitrogen fixing trees. These other ones are the fruit trees of varying types in amongst them all. Now if I cut one of these off, I've got a load of mulch to put down. And I've fixed the nitrogen here that's going to go towards those roots right there. So I've mulched, I've fixed nitrogen in the soil, and I've opened up to the sun. We better do that at the least stressful time of the year, the time of year we don't want shade, we don't need shade. Not the dry season in the tropics when we'd rather have the shade. Hopefully it's grown back again in the dry season. In the rainy season, that can come off in the tropics and the subtropics. In the time of year when there is less evaporation, you can remove those and open up to the sun. In the winter, in the temperate. You can think about the cycling of opening up to the sun, letting extra light in. When do you need that extra light? The other thing that's interesting here is that when the tree is flowering, when there's flowers on, they're usually yellow, often yellow flowers on a legume, not always, but often. When there's flowering, the flower is the sex organ of the plant. That's what gets it fertile. And after the flowering, you get seeds. The highest amount of nitrogen in the tree, apart from the bacteria, which is not part of the tree, is the seed and the pods. So seeds come in the pods. So if we have young trees, when the pods are on the tree, we've got all this nitrogen at the top. And we can drop that nitrogen down at that stage. You're going to get more nitrogen fix at the top. But if you cut the tree when it's flowering, there's more nitrogen at the bottom in the roots. Because the tree actually pulls nitrogen up from the roots, extra nitrogen, to produce the seed. So if you really get sophisticated about this, you can start to choose leguminous trees that flower at a certain time and can be pruned at a certain time in relation to what at the age of your fruit tree establishment is, or whatever tree establishment you're putting in. Because here you're time stacking, you're orchestrating the pioneering of a forest establishment. Whether it's fruit trees, whether it's timber trees, whether it's forage trees, whether it's pole timbers, fuel or whatever, when you're coming in on ground that isn't forested and you're going to establish forests, you're always going to go through some sort of stage like this. And the more you understand about it, the easier it is to get involved. There are, where I work, where I live in Australia most of the time in the subtropics, we have legumes in the form of plants, which farmers call cover crops. Your cover crop, I often use cowpea in the summer, only lasts 6 months. So you get cover crops, summer, winter. In winter I use dun pea, maple pea, vetch. Sometimes I use New Zealand lupin if I can get it. And they're just 6 months. They're a season. And I go to this is how I start. This is my primer. I condition the ground by maybe I scuff it up a bit. I don't plough it if I can help it. Maybe I plough it once. I'll admit that I sometimes plough the ground, right? I quite often rip the ground, put rip lines in, and then if I'm establishing a forest, I maybe run over it with a rotary hoe once, real careful. But straight away, almost behind the tractor, or at least the next day, I'm in with a cover crop seed. I'm in with one of these seeds. Straight away, if I can, I try and get myself well organised. And I plant 4 times more seed than the farm supplies tell you to put in on a cover crop. Because I'm only doing it once. I don't mind paying a bit extra for permanence. That extra $10 per acre means nothing over 2,000 years. If I'm as good as your average Moroccan date farm, 2,000-year-old food forests, what's $10? So I put 4 times the amount of cover crop you're supposed to put in, and I buy the inoculant from the farm supplies. I can buy inoculant for those. Oh, I missed an R. I can buy inoculant for those cover crops. You go to the farm supply, say, I want inoculant, please, for cowpea, or I want inoculant for dun pea in the winter, or vetch. And it's a bag of peat full of bacteria. Don't worry, he'll know what you're talking about. Farmers do this all the time. They inoculate their cover crops with bacteria before they plant them. They stick all this black peat on them that's actually got the bacteria that associates with that legume crop.
Are you moving so quickly to prevent the risk of the soil washing away?
Yeah, I'm absolutely paranoid about it, as you should be, right? And even if it's not steep ground or not slopey ground, bare soil I see as 2 things, right? I see it as a real problem, especially when I see someone else's field full of bare soil. With myself, I see it as, okay, it's a problem, but I'm moving real fast, and straight after I see the problem, it's also a great opportunity. I very rarely, if ever, have bare soil on my farm. When I do, the problem is a solution, and a great solution. I can move in real fast, and I can put a very exciting system in. It gives me an opportunity. It's a problem if I get a heavy rainfall that day. But even so, I have a solution to that too. I can cover it with cover crop seed, and I can scatter mulch it. And I can put a scatter mulch over the top. So just quickly, because we're going to go for a tea break. So just a quick line on time stacking. So there's your legumes. Right? I can put in now bushes by seed that last 1 year. I can put in also shrubs, let's call them small trees and shrubs, that last 3 to 7 years. at the same time on the same day. I can put in small trees that last 5 to 15 years. I can put in some trees, legume trees, these are all legumes, that last, say, 20 years. And I can put in some long-term legumes that last as long as the system, as long as the fruit trees, or as long as whatever trees are in, I'm establishing. I'm time stacking it, just like nature does, but I'm conducting the orchestra and I'm deciding what tunes played. And it's time stacking. Sometimes when I want it to time stack, I want them out now. My fruit tree's going so well, I can start taking most of them out now. And I can open up the space for my trees. So I often say that at the beginning of a system, I have 90% support. I never plant a fruit tree without planting 8 other trees, minimum. I never plant individual trees. So 90% support species. I get worse when I get excited. 10% productive species. And that's, I'm talking about mass.
Is that from the word go, or is that the...
That's a good question. That's at the beginning. And at climax, right, it's the other way round. It's 90% production and 10% support. They've switched in mass. So in 15 years' time in Melbourne and 10 years' time in Brisbane, more or less, you've gone from 90% support species in mass and 10% fruit on the day you started to the other way round, to 90% fruit and 10% mass, and you've stacked it out. You've only got these ones left. Where are these ones? They're around the outside. They're the outside fringe of your extending system, because it will extend out. It will grow that way, out, if you've got it right.
Does this add value? I mean, if you've got an established orchard which needs sort of rejuvenating, you sort of disperse this kind of stuff through it?
Yes. Yeah, done it many times. It means a little bit of funky repatterning, because you often got the grids, but what a lovely thing happens, the grids disappear, you can't find them. You go through in 10 years' time and go, you know what, this used to be an apple orchard. And they go, nah, get away. And you go, yeah, look, if you see that apple lines up with that apple, and that, you're actually in a grid pattern. And you go, well, I really got, oh yeah, really got to look for it, because this amazing spatial thing happens. It goes off and on, and the size of the land seems to go bigger. Like I said before, 1 acre feels like 5, because of there's all this space that you didn't see before.
When you're planting the cover crops, the low stuff, you're actually planting the bushes and everything all at the same time.
Well, all of those are seeds, right? And then these are all plants going in. Yeah, you can do them all on the same day. We'll come back to this.